Have you ever heard of the term half-life? Don't worry, it's not as complicated as it sounds. In simple terms, half-life is the time it takes for half of a radioactive substance to decay. Imagine you have a whole pizza, and you eat half of it. Now you're left with half a pizza, right? Half-life works similarly. Let's say we have a magical pizza that disappears over time. This pizza has a half-life of 1 hour. This means that after 1 hour, only half of the pizza will be left. After another hour, only half of that pizza will remain, and so on. This concept of half-life might seem strange at first, but it's a fundamental principle in science. It helps us understand how radioactive substances behave over time and has numerous applications in various fields. So, where does half-life come in handy in the real world? You might be surprised to learn that it plays a crucial role in many different fields. One such field is archaeology, where scientists use the half-life of carbon-14 to determine the age of ancient artifacts and fossils. By measuring the remaining amount of carbon-14 in a sample, they can estimate how long ago it was part of a living organism. This technique has revolutionized our understanding of history. It allows us to date objects that are thousands of years old. Medicine is another field where half-life is incredibly important. Radioactive isotopes, which are atoms with an unstable nucleus, are often used in medical imaging and treatment. For example, iodine-131, with a half-life of about 8 days, is used to diagnose and treat thyroid disorders. By administering a small amount of this isotope, doctors can track its movement and concentration within the body, providing valuable information about thyroid function. The concept of half-life is crucial here to ensure that patients receive the appropriate dosage and that the radiation exposure is kept to a minimum. Now let's try a simple calculation to see how half-life works in practice. Let's say we have 100 grams of a radioactive substance with a half-life of 10 years. After 10 years, half of it would have decayed, leaving us with 50 grams. After another 10 years, 20 years total, half of the remaining 50 grams would decay, leaving us with 25 grams. We can continue this process, and after 30 years we would have 12.5 grams left, and so on. As you can see, the amount of the radioactive substance decreases by half with each passing half-life. This exponential decay is a fundamental characteristic of radioactive substances, and is what makes half-life such a useful concept. Section 4. The importance of half-life. A small term with a big impact. From dating ancient artifacts to diagnosing and treating diseases, half-life plays a vital role in many aspects of our lives. It's a powerful tool that helps us understand the world around us and has led to countless scientific advancements. The concept of half-life might seem like a small and insignificant detail, but as we've seen, it has far-reaching implications. It's a testament to the interconnectedness of science and the power of understanding fundamental principles. Section 5. Keep exploring, the adventure continues. So the next time you hear the term half-life, remember that it's not just a scientific term. It's a key that unlocks a deeper understanding of the universe and our place in it. Keep exploring, keep asking questions, and never stop learning, because the world of science is full of wonders just waiting to be discovered. What other applications of half-life can you think of? How do you think this concept might be used in the future? The possibilities are endless.